everyone. Today we're going to start by talking about the coordinate plane. We're going to plot points, identify x and y intercepts. We'll be finding the slope of a line today, and we're also going to talk about vertical and horizontal lines, how to write those equations. If I look at the first section here, we're going to talk about some vocabulary. We're going to talk about the x-axis, which is the horizontal line on a coordinate plane where points are plotted moving left and right. And then we also have the y-axis, which is the vertical line on a coordinate plane where points are plotted moving up and down. So let's go ahead and label those over here on this coordinate grid. I'm going to start by labeling the x-axis. The x-axis is the horizontal line. So I'm going to put x-axis over here. And I'm also going to write x-axis on this side as well. Okay, so just looking at this picture, the horizontal line is what we call the x-axis. You can either move left or right on the x-axis. If you move to the right, you're going to have positive x values, and if you move to the left, you're going to have negative x values. The second one is the y-axis, which that axis moves up and down. So this vertical line right here is called the y-axis. I'm going to go ahead and label this top part y-axis and also this blank down here y-axis. If you move up on the y-axis, those are going to give you positive y values, and if you move down on the y-axis, that's going to give you negative y values. So just keep in mind, anytime we're moving to the right or moving up, you're going to have positive numbers. Anytime you move to the left on a coordinate grid or down, you're going to have negative values. Okay. I already talked about the x-axis and the y-axis. So now we're talking about an ordered pair. That's a point identified by an x and y coordinate. We always write the x coordinate first, and then we write the y coordinate. So let's look at an example. This point right here would be the point 2, 3. I know that because I would be moving to the right 2 units, so it's a positive value, and then up 3 units. Okay, we always list the x value first, which was 2, and then the y value second, which would be 3. Okay. Over here, I would have to move left 2, up 3. Okay, because I'm moving to the left, my x value is going to be negative, so I'm putting negative 2. And then up is a positive value, so I'm going to put 3. Okay. In the next quadrant here, I'm moving left 2, down 3. Left is negative, down is negative. So that'd be negative 2, negative 3. Finally, over here we go right 2, down 3. Remember, right is always positive and down is always negative. So this is going to be positive 2, negative 3. Okay. That's how we plot an ordered pair, x comma y. The origin is the point at the center of the coordinate plane. The origin is 0, 0. So just looking at the picture, this right here would be the origin. Okay, and the point or ordered pair is known as 0, 0. It's 0 to the left or right and 0 units up or down. Okay, we're not moving left or right or up or down at all, which is why it's 0, 0. Lastly, we're going to label the quadrants. There are 4 sections to the coordinate plane divided up by the x and y axis, and we're going to use Roman numerals to write the quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay. It moves in a C formation. Always start with the top right quadrant, that's 1, and then move your way around in a C, a big C, to label the other quadrants. Okay, looking at the top of the back, we're going to talk about x-intercepts and y-intercepts. The x-intercept is a point on the graph where the y value is 0. It's the place where the function crosses the x-axis. Typically the ordered pair is going to look like x comma 0, where you have a value for x and then the y value is 0. So let's take a look at this first picture. Here's the x-axis. Tell me where it crosses that yellow line, or the x-axis. Go across it here and here. All right, let's go ahead and write those x-intercepts. The first one looks like it's at about 0.5 to the right, and then not up or down at all on the y-axis. And then the second one looks like it's 2 to the right, so it's going to be a positive 2, and again not up or down at all on the y-axis. Okay, let's repeat this process. Try it on your own for the second picture. Here's the x-axis. Tell me the points where you see x-intercepts. The first place it crosses is right here, and we see another cross right there, and I think that's it. Okay, so let's approximate. For the first one, looks like we're going to the left. 1, 2, 3, 4. Ooh, I don't know. It's not quite to 4.5. I might say that that's negative 4.4, and then not going up or down at all. And then let's go ahead and approximate that second x-intercept as well. What is this point right here? Well, we're going left 1 and then a little bit more than 1.5. I mean, you might put negative 1.5, but I might put like negative 1.6 comma 0 for the x-intercept. The y-intercept is a point on the graph where the x value is 0, or a place where the function crosses the y-axis. So this is what the ordered pair looks like. It's going to have 0 comma y, where you're not going to go left or right at all, so the x value is 0, and then you're going to replace y with some constant. So looking at this first diagram, let me just highlight the y-axis. Remember, the y-axis is the vertical axis. And on the second diagram, I'll highlight the y-axis. Let's go ahead and star, it says to star the y-intercepts. So it looks like it crosses the y-axis right here in the first picture, and it looks like it crosses the y-axis right here in the second picture. So let's go ahead and write an ordered pair for the y-axis, for the y-intercept. Okay, here it looks like, we'll say that that's about 2.5. So I'll put 0 comma 2.5. Right, we're not going left or right at all, but we're going up 2.5. And then over on the second picture for the y-intercept, this point right here, it looks like that's at 1, 2, 3, 4. We'll say that that's 0, 4. Okay. For slope, slope characterizes the direction of a line. It's often referred to as rise over run. For the equation, we have the difference of the y values over the difference of the x values. Okay. We're going to use that equation when we have two ordered pairs. So x1, y1, and x2, y2. Okay. We have two ordered pairs. We're going to first do the difference of the y's, so we do y2 minus y1, and then we're going to do the difference of the x's, so we would do x2 minus x1. You never want to, or you want to stay consistent with the order. So notice that my arrows go in the same direction. It would be incorrect to do this. If you did y2 minus y1 and then x1 minus x2, see how the arrows are not pointing the same way? That would be incorrect. You want to make sure you're staying consistent. y2 minus y1, x2 minus x1. Okay, we're going to see a positive slope when the line goes up and to the right or down and to the left. So if you think about what a positive slope looks like, it's going to look something like this. Okay. If I go up and to the right, then I land on that line, or I can go down to the left and still land on that line. Negative slope. If you think about what negative line looks like, it's going to look like this. The line continues down and to the right or up and to the left. So if we start here and it goes down and to the right, then you land on that negative line, or up and to the left, you still land on that line. Zero slope is when the line continues left and right, but not up and down. So zero slope is going to just look like a horizontal line. An undefined slope is when the line continues up and down, but not left and right. So undefined slope is going to be used for vertical lines. So zero slope, just keep in mind that 0 divided by any number, 0 divided by number, that gives you a zero slope. Whereas if you have the opposite, or if you have a number divided by 0, then that's undefined. I mean, look at what that spells. See how this one spells no? That means you have an undefined slope. Draw an example of the above types of slopes. So we're just doing a sketch. Positive slope. Let's do a positive slope with 2/3. Okay, let me start at the origin. I'm going to go up 2 over 3, make a point there, and draw a line. That's a positive slope. See how when I move from left to right, the line goes up? Negative slope, let's just do negative 2/3. I'm going to start at the origin. I'm going to go down 2 and then right 3. 1, 2, 3. This would be an example of a line with negative slope. See how when you move from left to right, the line goes down, it's falling. Like, think about a person, right? Like if I start on the left and I have to move from left to right, I have to go up this big hill, so that's a positive slope, right? I'm going on an incline. Whereas here, if I start on the left-hand side and I move from left to right, whee, I would be sliding down that slide. That's a negative slope or a negative grade. Okay. Oops. Let's go ahead and take a look at 0. Zero slope can be any horizontal line. So I'll just draw this horizontal line. And an undefined slope is going to be a vertical line. So any vertical line that you want to draw. Try to do a better job of making this into a line. We can even use a shape here. Still a little off. I don't know, you get the idea. You can probably draw it better than me. We'll try it one more time to make it a nice straight line. There you go. That looks good. Okay. Again, if you think about your little person, if I start on the left, do you see how this person would be able to walk on the land just fine if he's moving from left to right? But if I have this person, I mean, unless it's Spider-Man, there's going to be no way to go up that wall, right? So that is what we call an undefined slope. Think about how it would be impossible to walk up that wall. Using the 2 points, find the slope of the line and classify the type of slope. Okay, so this is where we're going to use our formula. I'm going to label the first point my first point, x1, y1, and I'm going to label the second point my x2, y2. Okay. And I'm going to use this formula y2 minus y1 over x2 minus x1. And I'll go ahead and zoom in. Start with y2 minus y1. y2 minus y1 will have 3 minus a negative 1 over x2 minus x1. I use purple. x2 minus x1, we would get 4 minus a negative 2. Okay, simplify this. Remember, minus a negative really becomes a plus, so we'd have 3 plus 1, so that would be 4. And 4 minus a negative 2, that's really going to become a plus. 4 plus 2 is 6. Always reduce. Both of these are divisible by 2. So 4 divided by 2 would be 2. 6 divided by 2 would be 3. So my slope's 2/3, and that is a positive slope. Okay, repeat the same process. Here for the next one, I do y2 minus y1. That's going to be 9 minus 6 over x2 minus x1. x2 minus x1, we'd have negative 3 minus a negative 3. Reduce. 9 minus 6 would be 3. Negative 3 minus a negative 3. Remember the double negatives turn into a plus, so we get 0. We get a number over 0. What does that spell? No. So what is my slope? My slope would be undefined. That's, remember, for those vertical lines. Okay, same thing over here. We do y2 minus y1, 2 minus 4 over x2 minus x1. That'd be 3 minus 2. Reduce. We get negative 2 over 1, which anything divided by 1 is just itself. So we would get negative 2. And that would be a negative slope. So falling from left to right. The last part says horizontal and vertical lines. Plot and label 3 points on each of the graphs and answer the questions below. Let's go ahead and take a look at this horizontal line first, and then we're going to go ahead and take a look at this vertical line. For each problem, what we want to do is plot and label 3 points on the graphs. So for the red line, the horizontal line, let's do this point, let's do this point, and let's do this point. Okay, and for the vertical line, let's do this point, we'll do this point, and then we'll do this point. Okay, I'm just picking 3 points on each graph. Okay, so let's start with the horizontal line. Here I'm going left 3, up 3, so this will be the point negative 3, 3. Here I'm going right 1, up 3, so this would be the point 1, 3. And then here I'm going over 4, up 3. Just starting there, what do you notice about all 3 points? All 3 points have the same y value. That's interesting. So let's just make a note of that. For horizontal lines have the same y value. Okay, let's label the points on the vertical line. Here we'd be going left 1, up 4, so we'd have negative 1, 4 for the top point. Left 1, up 1, so that'd be negative 1, 1. And then left 1, down 3, so I'd have negative 1, negative 3. What do you notice about all 3 points for the vertical line? All 3 points for the vertical line have the same x value, right? They're all negative 1. So let's just make a note of that, right? For vertical lines, they all have the same, all the points have the same x value. Okay, let's answer these conclusion questions below. It says, what do you notice about the x values? Which one had the same x value for all 3 points? That was the vertical line, right? So it's interesting. For horizontal lines, it wasn't really important. There were different x values. But for the vertical lines, they all had the same x values. Okay, in this case, they were all what? All the x values were negative 1. All the x values were equal to negative 1. What do you notice about the y values? Which type of line had the same y value? That was the horizontal line, right? The horizontal line had the same y values. Okay, so here I'm going to put horizontal lines had the same y values. In this case, what were all the y values equal to? 3. All the y values were equal to 3. Whereas the vertical lines, those were just different y values, not really anything significant. All right, so to write our final conclusion, the equation of every horizontal line is in what form? Remember, horizontal lines all had the same y value. So they would have the form y equals some number because every point has the same y value. So if you see a horizontal line, that's of the form y equals. The equation of every vertical line is of the form what? Remember, for every vertical line, there was the same x value. So every vertical line has the form x equals some number because every point has the same x value. So if you see a vertical line, it's kind of counterintuitive. That's going to be of the form x equals some number. All right, and that's it.